This weekly test too was done very well. So I'm not even sure I need to do a memo for this, but let's just go through each of the bits questions just to make sure for some who may not have got it right. So DMSO is dimethyl sulfoxide. Two methyl groups. Sulfur's got one oxygen on it, double bonded to it, and this is dimethyl sulfoxide. And just something you need to learn. This over here is toluene, so it's a benzene ring with a methyl group on it. Okay, a lot of you got that right over there. And then the toluene is the common name that we use for that solvent. I had some funny answers there, but just that's something you should remember. Okay, these questions over here are generally answered quite well. So we look at this over here. We recognize we've got a nucleophile on the nitrogen. This one's got a Bock protection group on it. I'll just say a few words just now about that at the end of this memo. We recognize we've got an acid chloride over there. So actually 1,2 addition is going to predominate always on this. And so the product is the 1,2 addition product. So that we get the nitrogen, and it's a 6-membered ring with the Bock group still intact. All right, you've got 2 marks for that. This one over here, sodium borohydride, is a reducing agent. It does 1,4 reductions, but it's not going to reduce an amide. So this remains completely intact, and it's just the double bond that gets reduced, and so everything else remains the same on there like that. And then the thiophenol over here. Now, a lot of people had the right idea, but they got it wrong, just in the product. The thiol, the sulfur, is a soft, and so you most got this right. It's going to do a 1,4 addition at this point over here. Where you got it wrong was just actually just the way you drew out the product. Some people just lost the thiol, and they wrote a pH for phenol. It's not. It's sulfur is bonded to this carbon, which is then bonded to the phenyl, which is pH over there. So you needed to write it out like this. Some people wrote some very strange things over there, and I marked that incorrectly. But I could see you had the right idea. It was a 1,4 addition because it's a soft nucleophile, so it wants to do 1,4. So that was answered very well. And then this last question, yeah, the majority of you got this correct. I'm very happy about that because clearly, yeah, you're understanding the basic mechanism here is that the first step, triethylamine, is not strong enough to deprotonate over there. So triethylamine needs to add to the TMS. We kick out the chlorine, and then the first intermediate, and most people had all the equilibrium arrows correct as well, which is fantastic. So we go TMS, it's positively charged, just fill in the rest over there. And we've got 2 hydrogens over here. The triethyl amine, lone pair of electrons on the nitrogen, is the base. So you can see that. Picks up the hydrogen, this kicks in there, that kicks in there, and we get our product, which is that's the product over there. So 2 marks. Okay, so that was done very well. So that's the memo for the test. Just to kind of go back to, I promise you that I just talk about the Bock group over here, what this is. Bock actually stands for tertiary butyl oxycarbonyl. If I had to draw that out over there, it'll look like this. Let me draw the piperazine starting material. Like this, that's the H. So if I draw that out over there, it is a double bond O, an O, and then a T-butyl group like that. And this part here is called Bock for tertiary butyl oxycarbonyl. All right, BOC. You can go and Google that. And this is an example of a protecting group. And again, I'll just continue. You can turn off the video now if you don't want, you're not interested. But the reason we're using that is if we did not have that Bock group over there, all right, so if we took that Bock group out, we would have another NH. When I tried to do a reaction with this acid chloride is going to react with that nitrogen, but another molecule of acid chloride is going to react with that nitrogen over there. So the product would have the reaction occurring twice. It's impossible to control just going on once. And so we protect the Bock group with a Bock group. We can do that a bit easier, protect that, and then at the end of this, we can selectively just get it going onto one nitrogen, and later on, we can remove this Bock group under specific conditions. So you can go and look that up if you want to be interested. It's good knowledge to know if you're interested in continuing on with chemistry and studying at an honors level. It's good to go and look that up. All right, there we go.